Hi everyone, and welcome to this lecture video on atomic structure. We're going to be looking at the ebook chapter 1, lesson 1. So after this video, you should be able to define the term isotope and interpret atomic symbol notation. You should also be able to calculate the number of protons, neutrons, and electrons for different isotopes and ions. So let's begin. Let's first talk about what an atom is. An atom is the smallest unit of matter that corresponds to an element on the periodic table. So you might be familiar with elements such as carbon, lithium, hydrogen, helium, etc. If you go down to the smallest level within those elements, you find the atoms. Those are the smallest components that correspond and are the identity of an element. And an atom consists of multiple parts. If you break down an atom, you get its nucleus, which is in the center, and the electron cloud, which surrounds the nucleus. And within the electron cloud, you have one or multiple electrons. Within the nucleus, you have protons and neutrons. And what we see here is, if you look at the difference in scales, that atoms are mostly empty space. Again, within the atoms, you have protons, electrons, and neutrons, and each of them has a different mass, and they also have different charges. So when we take a look at the masses, look at the difference in scale between protons, electrons, and neutrons. Protons and neutrons are on the same order of magnitude. They're essentially identical, and so they have the same mass. This right here, AMU, stands for atomic mass unit. And when you look on the periodic table, those values that are given there are in units of AMU, atomic mass units. And since there's an order of magnitude difference of 4, so 10,000, we can essentially approximate the mass of an electron to be 0. But what we do see is that electrons and protons both have charges. And what's most important here is these numbers, that a proton has a positive 1 charge and an electron has a negative 1 charge. These other charges here, this uses the unit coulomb, and you don't need to know a whole lot about that for this class. But what is important to note is that essentially all of the mass of an atom is within the nucleus. Now, taking a look at the periodic table, we talked about these are the different elements. We're going to learn how to interpret the different numbers and symbols that are here. But something to point out is that the periodic table has meaningful relevance for our living lives. So within living systems, there's about half a dozen elements that are very prevalent and that make up the majority of them. And that's hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. Then you have some other elements that are abundant within living systems. These tend to be some of the metals, although chlorine here is a non-metal. Although these are present in the form of monoatomic ions. And then you have a handful of other elements that play important roles in some of the processes that happen, but they have very, very small amounts. And then the remaining elements are not used in biological systems, but they are very important to chemical industry and medicine and other applications of chemistry. And what we see here is, on this version of the periodic table, you have one number above each element. And this number here, in this case, this is boron and carbon. This is what we call the atomic number. And the number of protons is equal to the atomic number. And we'll go into more depth about that in just a minute. So, if we wanted to identify this element, we've zoomed in on it, and we assume that everything is represented. What we see is that within the nucleus we have 1, 2, 3, 4, 5, 6 protons. And since we have 6 protons, that tells us that we have carbon. So an element is defined by its atomic number. The atomic number is the number of protons in the nucleus. In this case, we have 6, so that gives us the element carbon. Now, if we happen to have a 7th proton, that would be 7 protons is nitrogen. If we had 8 protons in the center of the nucleus, that would be oxygen. Let's talk now about what isotopes are. So an isotope is a different version of an element, essentially. So it's going to have the same number of protons as an element, but differing numbers of neutrons. And as we saw earlier, neutrons and protons weigh the same amount. And so by looking at the actual mass number, or the atomic mass of a given element, we can determine the number of protons and neutrons. So looking at this notation here, what you can see is we represent the total mass of an element using the mass number. The atomic number, again, represents the number of protons. And then the atomic symbol is what you see on the periodic table. So let me show you an example here with carbon. So this is carbon. It has, it's defined by having 6 protons. That's what this number represents. Again, the number of protons. And then this number represents the number of protons and neutrons. And so what we can infer is that since there are 6 protons and a total mass of 12, that there must be 6 neutrons as well. And so this, you'll see this a couple different ways. This might be written as carbon 12 or kind of like a reverse exponent on a carbon. And that refers to this isotope, this carbon that has 6 protons and 6 neutrons. Now, in this case, we can compare and see what's going on here to see what isotopes we have here. On the left, we have 1, 2, 3, 4, 5, 6 protons, and 1, 2, 3, 4, 5, 6 neutrons. On the right, we have 1, 2, 3, 4, 5, 6 protons, and 1, 2, 3, 4, 5, 6, 7, 8 neutrons. So what we see then is that both of these are carbon because they have 6 protons each, but these are also isotopes because they have different numbers of neutrons. On the left, we have carbon 12, and on the right, we have a total of 14 AMU for its mass, and so that would be carbon 14. We're going to now turn to what are called ions. And ions are charged atoms that have unequal numbers of protons and electrons. To the right of the elemental symbol, you have either a charge or the absence of a charge. When there's just a positive or negative sign, it's implied that there's also a 1 there. So what we see here is that carbon in this case is neutral. Potassium has a positive 1 charge, and sulfur has a negative 2 charge. And to determine the number of electrons that are present requires a bit of deduction. So if there's a balance of protons and electrons, we end up with a neutral charge. If there is a deficient number of electrons, we end up with a positive charge. And if there's an abundance of electrons, then we end up with a negative charge. So what we see here is that there are 6 electrons with carbon, there are 18 electrons with potassium, and there are 18 electrons within the sulfur ion as well. And down here, this just summarizes what we said earlier. Now there are names for these types of ions. If it's neutral, we just call it an element. If it is positively charged, it is a cation. And if it is negatively charged, it's an anion. All right. Now this is going to be your opportunity to practice. I want you to, I'm going to put up the question here. Now pause the video before you move on and before to see me working through it. So you should pause the video and you should try to solve this problem on your own. All right, welcome back. Let's see if you got the correct answer. So the question is, of the following, which number does not represent a number of protons, neutrons, or electrons found in one of these two ions? And the way you want to think about this is by looking at comparing the charges to the number of protons, and then also the sum of the protons plus the neutrons. So we can do these in any different order. But what we can see here is that there's 27 protons as represented there. For the electrons, we determine that by taking the difference between the protons and accounting for the charge. So we know that we have to have excess protons, and there's 2 of them, which means that we have fewer electrons, 2 fewer electrons, there's 25. And then the neutrons is found by taking the 60, and that's equal to 27 plus some number. When we solve for that number, we get 33. Here for the iodide ion, this is our number of protons, so 53. The electrons, we see here now that we have excess electrons and a value of 1, so we have to have 1 more, 54. And then neutrons is found by taking the total mass, the atomic mass there, and that's equal to the number of protons plus the number of neutrons, and the number of neutrons in that case then is 78. All right, hopefully you got those. If not, you are welcome to ask around on Piazza and get some help there, or come to office hours or recitation. Thanks for watching, and see you next time.